Dear students, welcome again. So इस लेक्चर ਦੇ ਵਿੱਚ ਅਸੀਂ ਅੱਜ इंटीग्रल इक्वेशनस ਨੂੰ डिफाइन करांगे। डिफाइन ਕਰਨ ਤੋਂ ਬਾਅਦ ਅਸੀਂ ਦੇਖਾਂਗੇ ਉਹਨਾਂ ਦੇ डिफरेंट टाइप्स ਕਿਹੜੀਆਂ ਹੈ और फिर ਅੱਗੇ ਕਿਵੇਂ ਆਪਾਂ ਉਹਨਾਂ ਨੂੰ यूज़ करना। So let's see the objective of this lectures. So first one is introduction, Abel's problem, then linear and non-linear integral equation, and then Fredholm integral equation and Volterra integral equation. Students, ये प्रॉब्लम जिहड़ी है ये Abel's प्रॉब्लम तो शुरू होएगा और अज दा जिहड़ा साडा टॉपिक है वो फ्रेडहोम इंटीग्रल इक्वेशन और वोल्टेरा इंटीग्रल इक्वेशन दे नाल इंट्रोडक्शन दे उत्ते जाके असीं खत्म कर देंगे। So myself is Dr. Amanpreet, PG Department of Mathematics, Khalsa College, Patiala. Let's see introduction. Integral equation, the introduction is very interesting. Since we have mathematical model and this model can be solved by differential equation, by partial differential equation or by ordinary differential equation. To solve partial differential equation or ordinary differential equation, we have another method, and the method is integral equations. So this integral equations are very helpful to solve partial differential equation or ordinary differential equation. Although differential equation includes boundary value conditions or initial conditions. दो तरह दी होंदियां साडे कोल, जां तां बाउंड्री वैल्यू कंडीशन होणगियां जां इनिशियल वैल्यूज कंडीशन होणगियां। सो इन्हां दोनां नूं ही सॉल्व करन दे लई असीं इंटीग्रल इक्वेशन जिहड़ा है वो बनावांगे और उस इंटीग्रल इक्वेशनस नाल जिहड़ा है उन दोनों बाउंड्री कंडीशनस नूं ते इनिशियल कंडीशनस नूं ईजी करके सॉल्व कर लांगे। सो लेट्स सी द फर्स्ट इज एबल्स प्रॉब्लम। एबल्स दी की प्रॉब्लम है साडे कोल। सो एबल्स ਜਦੋਂ डिफाइन किया गया एबल की प्रॉब्लम तो वो प्रॉब्लम नूं जिहड़ा है वो इस ग्राफ दे विच असीं देखिया, एक एक्स एक्सिस है एक वाई एक्सिस है। लेट पी एंड क्यू बी टू नेबरिंग पॉइंट सच दैट ओ क्यू इज एस डिस्टेंस। ओ क्यू जिहड़ा है वो साडे कोल एस डिस्टेंस है। ओ क्यू इज इक्वल टू एस। द वेलोसिटी ऑफ द पार्टिकल एट क्यू, द वेलोसिटी ऑफ द पार्टिकल व्हेन पी particles start from P and come to at Q. P is x, y and Q is xi and neta. This is a Roman language, this xi and neta. So when P approach to Q, the velocity of the particle is velocity. We always knows that velocity is denoted by ds by dt. So this is equal to negative of square root of 2g. G is the due to gravity and this is x minus xi. The distance covered from P to Q, where P and Q are very neighboring points. So when I separate the variables, so this we got t and t dt is equal to ds by minus 2g root x minus xi. So from P to Q, this is a minus P to Q integral ds over square root of 2g into x minus xi. Student, ਇੱਥੇ ਕੀ ਹੋਇਆ ਕਿ ਇੱਥੇ ਅਸੀਂ ਇੰਟੀਗ੍ਰੇਸ਼ਨ ਕੀਤਾ डी वेरिएबल सैपरेट करके dt ਨੂੰ ਇਸ ਪਾਸੇ शिफ्ट ਕੀਤਾ, ਇਹਨੂੰ ਦੂਸਰੇ ਪਾਸੇ शिफ्ट ਕੀਤਾ and we got integral from P to Q. So integral from P to Q is negative. So negative ਅਸੀਂ ਰਿਪਲੇਸ ਕਰਤਾ ਪੋਜ਼ਿਟਿਵ ਨਾਲ और ਇਹ ਜਿਹੜੀ ਲਿਮਿਟ ਹੈ ਇਹਨੂੰ ਅਸੀਂ ਚੇਂਜ ਕਰ ਲਿਆ Q to P. So this is we have t is equal to Q to P. But this ds ਨੂੰ ਅਸੀਂ ਹੁਣ ਜਿਹੜਾ ਹੈ ਉਹ ਆਪਣੇ xi ਦੇ ਵਿੱਚ ਲੈ ਕੇ ਆਉਣ ਲੱਗੇ ਹਾਂ। if the shape of the curve is given, then s can be expressed in the terms of xi and hence ds can be expressed in terms of xi. So let ds is equal to uxi and dxi. uxi into dxi, that means we integrate this in function with respect to xi. So we got t from 0 to x uxi dxi upon 2g x minus xi square root. So this is called Abel's integral equation. This is called Abel's integral equation, and from here we will draw Volterra's integral equation and Fredholm's integral equations. So let's see. Abel treat the above problem in modified form by finding the curve for which the time t of descent is given function of x, say fx. Thus we are led to the problem of finding the unknown function u from the equation. So ਅਸੀਂ u find करना चाहते हैं. u find ਕਰਨ ਦੇ ਲਈ ਜਿਹੜੀ method ਅਸੀਂ use ਕਰ ਰਹੇ ਹਾਂ ਉਹ method ਦਾ ਨਾਮ ਹੈ integral equation. So definition is an integral equation is an equation in which an unknown function appear under more integral sign. This is the unknown integral, that is kxt. K is also known as kernel, and we will see how this kernel behave in the integral equation. So fx is equal to integral kernel kxt, yt and dt. Students, this kernel is separable also. This kernel is symmetric. So let's see what happens. So yx is equal to lambda. Lambda is a scalar which may be real or complex. A to b kxt yt dt is equal to f of x, or fx is equal to a to b kxt yt square dt. So linear, and these three are the forms of integral equation. Now we characteristics these three into linear and non-linear integral equation. So linear integral equation, an integral equation is called linear if only linear operations are performed in it upon unknown functions. An integral equation which is not linear is known as non-linear integral equation. This is a linear integral equation. This is also linear integral equation, and the most general type of linear integral equation is of form yx is equal to fx plus lambda a to b kxt yt dt. So this is our base of this lecture. Gx is equal to f of x plus lambda a to b kxt yt dt. So the next slides next lecture is based on this linear integral equation. Student must be very careful about this linear integral equation. So first, where the upper limit may be either x or a fixed, that is b, the function f, g and k are known function, while y is to be determined. Lambda is non-zero, real or complex parameter. I already explained this. The function kxt is known as kernel of the integral. The remarks one is just the constant lambda can be incorporated into kernel this, and lambda jehda hai enu incorporate ਕੀਤਾ ਜਾ ਸਕਦਾ xkt ਦੇ ਵਿੱਚ. However, many application lambda represent a significant parameter which may takes on various values in the discussion being considered. So next is, if gx is not equal to 0, the previous result is known as linear integral equation of a third kind, when gx is equal to 0, and we got this, and which is known as the linear integral equation of 0. If gx is equal to 0, then this is the linear integral equation of first kind. Again, if gx is equal to 1, this reduces to this, and this is known as linear integral equation of second kind. So all these things we will discuss step by step. So first one is Fredholm integral equation definitions. Definition is an integral equation of the form gx fy is equal to fx plus lambda a to b kxt yt dt. मैं ਹੁਣੇ previous slides ਦੇ ਵਿੱਚ ਦੱਸ ਕੇ ਹਟਿਆ ਕਿ ਇਹ ਸਾਡੀ ਜਿਹੜੀ ਹੈ ਉਹ ਮੇਨ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ ਹੈ, ਬਟ ਜੇ ਇਹਦੇ ਵਿੱਚ ਅਸੀਂ ਫਸਟ ਕਾਈਂਡ ਦੀ ਫ੍ਰੈਡਹੋਲ ਇੰਟੀਗਰਲ ਇਕੁਏਸ਼ਨ ਦੇਖਣਾ ਹੋਵੇ ਤਾਂ ਉੱਥੇ ਅਸੀਂ gx ਨੂੰ ਕੀ ਕਰ ਦਿਆਂਗੇ, 0 ਕਰ ਦਿਆਂਗੇ. when gx is equal to 0, we got fx plus lambda, this is fx plus lambda a to b kxt yt dt is equal to 0. This is the first Fredholm integral equation of first kind. Similarly, Fredholm integral equation of second kind ਦੇ ਵਿੱਚ gx is equal to 1. ਇੱਥੇ ਤੇ gx ਨੂੰ 1 ਕਰ ਦਿਆਂਗੇ ਹੁਣ 1 ਕਰਾਂਗੇ ਤਾਂ ਇਹ ਆਏਗਾ yx is equal to fx plus lambda a to b kx t yt dt. So this is the second kind of Fredholm integral equation. Then we have homogeneous Fredholm integral equation of second kind. For homogeneous, we have fx is equal to 0. Fx is equal to 0. So we got gx fy is equal to lambda. So gx fy is equal to lambda a to b k x t y t. ਇਹਦੇ ਵਿੱਚ ਪੁੱਟ ਕਰਾਂਗੇ ਅਸੀਂ ਕਿਉਂਕਿ ਇਹ ਹੈ homogeneous Fredholm integral equation of second kind ਦੇ ਵਿੱਚ ਜੇ ਅਸੀਂ fx ਨੂੰ 0 ਪੁੱਟ ਕਰ ਦਈਏ ਤਾਂ ਇਹ ਸਾਡੇ ਕੋਲ homogeneous form ਬਣ ਜਾਏਗਾ. And then we have third kind is same. This one is known as third kind of integral Fredholm integral equation. Similarly, we have Volterra's. Now see, Volterra's integral equation definition is an equation of the form. The only difference is here we have a to x variable, where in the previous Fredholm means a to b. Volterra, it is a to x. Volterra means variable limit and Fredholm means constant limit. So similarly, Volterra integral equation of first kind ਦੇ ਵਿੱਚ ਅਸੀਂ ਜਿਹੜਾ ਹੈ gx is equal to 0 ਕਰਾਂਗੇ. gx 0 fx plus lambda a to b a to x kx t y yt is equal to 0. And then we have Volterra's integral equation of second kind. Student, second kind ਦੇ ਵਿੱਚ ਕੀ ਹੋ ਜਾਏਗਾ? gx is equal to 1 and gx is equal to 1, we got this integral. And then homogeneous Volterra integral equation when fx is equal to 0, and we got this. And similarly, the last one is Volterra's integral equation of third kind, and the third kind is the same which we are defining as singular integral equation. The singular integral equation is the equation where either the limits are infinity or the integral becomes infinity. Either the limits are infinity or the integrals become infinity. These are known as singular integral equations. Then special kind of kernel, I already tell you, we have symmetric kernel, that is kxt is equal to k bar tx, that is complex symmetric Hermitian, complex symmetric or Hermitian kernel. And similarly, if it is a symmetric only, that means the real, then kxt is equal to ktx. But the separable or degenerate kernel is more important, and the separable kernel is kxt is equal to summation I from 1 to n gix hit. This is a separable or degenerate kernel. So this is the lecture. In next lecture, we will see how we solve these integral equations and more general applications of this Fredholm integral equation and Volterra's integral equation. Thank you, students.